For the circuit diagram of Wheatstone bridge shown in the figure, for the circuit diagram of Wheatstone bridge shown in the figure, use Kirchhoff's laws to obtain its balance condition. Use Kirchhoff's laws to obtain its balanced condition. Now the circuit diagram is circuit of Wheatstone bridge. Galvanometer, and R1, R2, R3, R4. We are marking the resistors as R1, R2, R3, R4. This is the given circuit. For this given circuit, obtain the balance condition using Kirchhoff's law. Now we know that because it is given it's under balanced condition, for a Wheatstone bridge under balanced condition, the current to the galvanometer is 0. So while applying the Kirchhoff laws, we can neglect this galvanometer. So before starting, let us mark all these nodes as A, B, C, D, and you can make a note of it. I'll give you a note here. Note. In a balanced Wheatstone bridge, no current flows through the galvanometer, or current through G is 0, so you can neglect G when you are applying the Kirchhoff laws. Now let us mark the currents in the circuit. Let us say the current drawn from the battery is I, and let us say the current through R1 is I1. Now by KCL, the current through R4 will be equal to I minus I1. Now because the bridge is balanced and no current flows through galvanometer, the I minus I1, but it comes to terminal B, point B, node B. The whole current flows through R2. Therefore the current through R2 is also equal to I1. Similarly, the current through R3 will also be equal to current through R4, which is equal to I minus I1. First, we marked a capital I as the current drawn from the battery. Then we marked I1 as the current through R1. And applying KCL at node A, we get current through branch R4, resistor R4, is equal to I minus I1. Similarly, there is no current flowing through galvanometer, and hence current through R2 is equal to current through R1. Similarly, current through R3 equal to current through R4. So we have used, for the distribution of current, we have used Kirchhoff's current law or Kirchhoff's first law. Now consider the loop ABDA. consider the loop, consider loop A B D A. Applying KVL, A B D A. First comes I1 R1, and according to sign convention it is minus I1 R1. Next comes the branch with galvanometer G, and we know that the current through G is 0, so we can neglect this. And then we have I minus I1, so that is according to the sign convention it is plus I minus I1 into R4 equal to 0. Or I1 R1 equal to I minus I1 into R4. This is one equation. Now let us consider another loop that consists of B, C, D, B. Consider loop, consider loop B, C, D, B. So here first is I1 R2, that is minus I1 R2, and then we have I minus I1 into R3, so that is plus I minus I1 into R3, I1 into R3, so this I'll write it clearly, I1 into R3, and then we have a branch which consists of galvanometer, which is neglected because there is no current, equal to 0. Or rewrite this equation as I1 into R2 equal to I minus I1 into R3. Equation number 2. First we have distributed the current using Kirchhoff's current law, and now we have written voltage equations using Kirchhoff's voltage law. Now by using equation 1 and 2 we can find out the condition for the balance bridge. I will write here only, so let me draw a line here. Now divide equation 1 by equation 2. Equation 1 divided by equation 2. What does it give us? Equation 1 by equation 2 gives I1 R1 divided by I1 R2 equal to I minus I1 into R2, sorry, not R2, R4 divided by I minus I1 divided by I minus I1 into R3. Therefore, so now simplify this equation. I1 I1 cancel, here I minus I1 get cancelled. So the remaining terms are R1 by R2, which is equal to R4 by R3. Therefore, in the given circuit, the condition for the bridge balance is R1 by R2 must be equal to R4 by R3. R1 by R2 is equal to R4 by R3. The bridge balance condition actually means that the potential at B is equal to potential at D, or the potential difference between B and D is 0. If the potential is 0, there is no current flowing through the galvanometer. So the given condition is R1 by R2 is equal to R4 by R4. Therefore, the necessary and required balanced condition for the balanced bridge is R1 by R2 is equal to R4 by R3. R1 divided by R2 is equal to R4 by R3, and see clearly where are these resistance come, like how they are connected, R1, R4, R2 and R3. So you can write here, this is the necessary and required balanced condition. Required balanced condition of Wheatstone bridge. Condition for the bridge. This is the necessary and required condition for the bridge. Bridge here actually it is Wheatstone bridge.